This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy, we go deep and lightly surface the big ideas. You know, usually when we sit down to talk about a historical cold case, we're all picturing, like, detectives in a dusty, dimly lit room.
Right, staring at faded Polaroids pinned to a corkboard.
Exactly. Connecting dates and locations with red string. But today, we are going to look at what is arguably the ultimate evolutionary cold case. And that is the sudden, totally inexplicable extinction of the Neanderthals.
It really is the ultimate mystery.
It is, and for decades, paleoanthropologists have been standing in front of their own version of that corkboard. You know, they have the ancient fossilized bones, they have the chipped stone tools.
And the ice core samples giving us all that climate data?
Right, the ice cores. And they've just debated relentlessly about why our closest evolutionary cousins, these are beings who survived for hundreds of thousands of years, why they just vanished from the Earth.
Yeah, and the theories are always so cinematic, aren't they?
Oh, totally. As an action movie. Was it a brutal ice age that froze them out? Was it a prehistoric turf war with us, with modern humans, out-competing them for territory?
Or did they simply run out of mammoths to hunt? We naturally gravitate toward those grand, sweeping narratives.
We really do.
We want our evolutionary history to sound like a struggle against the elements, a clash of species. So we look for external threats, the things that leave obvious physical evidence behind.
Like a crushed skull.
Exactly. Or a sudden change in the fossilized pollen record that points to a really harsh winter.
Which makes sense because that's what we can actually dig up, right? We can hold those things in our hands. We are stepping away from the frozen tundra today. We are putting down the flint spears, and we are walking straight into a modern maternity ward.
Which sounds crazy, I know.
It does, because the missing puzzle piece to this prehistoric extinction event might not be a climate disaster or a war. It might actually be a pregnancy complication.
And not just a generic complication. We are talking about a highly specific, uniquely human medical mystery. We are exploring a theory today that bridges an incredible gap. It takes what happens in high-tech delivery rooms right now, today, and uses it to explain what was happening in isolated caves 40,000 years ago.
It requires us to completely reframe how we think about survival, and I am so ready for this.
Me too.
So our source material today is a truly fascinating paper, and it was published in the Journal of Reproductive Immunology in 2026. The title is a bit of a mouthful, but it lays out the roadmap perfectly. It's called Eclampsia: Why Reproduction Has Probably Been Very Problematic in Neanderthals, The Fabulous History of Preeclampsia.
By researchers Robillard, Saito, and Decker.
That's the one. And our mission for this deep dive is to investigate how this single, deeply ingrained biological vulnerability might have actually dictated the survival or really the total demographic collapse of an entire branch of the human family tree.
You know, to appreciate the gravity of this paper, you really have to realize how unconventional the methodology is.
Oh, yeah.
You have paleoanthropologists who spend their entire careers analyzing, the curvature of an ancient femur or the shape of a jawbone.
Just looking at bones all day.
Right, to understand human history. But Robillard and his colleagues are suggesting that the real clue, the actual smoking gun of human evolution, doesn't fossilize at all.
It's invisible in the dirt.
Totally invisible.
Yeah.
It involves soft tissue, temporary organs, complex maternal immune responses, things that leave absolutely zero trace in the geological record.
It is the ultimate scientific irony. We have been digging in the dirt for over a century looking for answers, but the real clue has been happening right in front of us in delivery rooms every single day.
Every day.
So, to you listening, whether you've had kids, whether you plan to, or if you just love a really good paradigm-shifting evolutionary mystery, you are about to look at human survival in a completely new way. We are going to unpack why having a big, beautiful, complex brain comes with a potentially deadly biological price tag.
And to even begin to understand that price tag, we have to look at just how incredibly strange and honestly, how dangerous human pregnancy actually is.
Yeah.
Especially when you compare it to the rest of the mammalian kingdom, because we tend to think of reproduction as this perfectly natural, seamless process.
Because every living thing does it.
Right. Well, every living thing does it, so it must be easy. But for humans, the mechanics are wildly anomalous.
Let's get right into that anomaly, actually, because this brings us to a 5,000-year-old medical mystery and what the paper calls the 4,300 to 1 odds.
This is such a wild statistic.
It is. This was the first statistic that made me realize how blind I've been to human biology. So eclampsia, which is clinically defined by these generalized grand mal seizures during pregnancy, and its precursor, preeclampsia, they are completely, entirely unique to us.
That is the biological crux of the entire mystery. I mean, there are approximately 4,300 known mammal species on planet Earth. We are talking about dogs, blue whales, elephants, mice, and even our closest genetic primate relatives, right? Like chimpanzees and gorillas.
Yeah, all of them.
Out of all of them, we Homo sapiens are the only species that naturally experiences this specific systemic hypertensive syndrome during pregnancy.
Out of 4,300 species, I mean, I'm picturing a horse giving birth out in a field.
Right.
The process starts, the foal is delivered, and within an hour, that baby horse is standing up on wobbly legs, and the mother is casually eating grass like nothing happened.
Like it was just a regular Tuesday.
Exactly. Meanwhile, human reproduction is this incredibly dangerous, highly medicalized, protracted event. And eclampsia is the absolute extreme edge of that danger.
The contrast is just stark. For most mammals, pregnancy and birth are relatively low-stakes physiological events. I mean, compared to the human experience anyway.
Yeah.
But because eclampsia is so dramatic, you have a pregnant woman seemingly fine one moment and then suddenly experiencing severe, life-threatening convulsions the next. It didn't just catch the attention of modern obstetricians.
No, it goes way back.
Way back. It caught the attention of the very first human beings who ever figured out how to write things down.
The history detailed in this source is staggering. The paper points out that eclampsia is actually the very first human disease ever explicitly documented in written history.
First ever. Let that sink in.
We are talking about medical records dating back over 5,000 years to around 3,000 BC.
And when you view that through the lens of medical anthropology, you realize how rare that level of historical continuity is.
What do you mean by that?
Well, if you look at most ancient texts, they don't give us clear, undeniable descriptions of specific diseases that we can map perfectly to modern diagnostics.
Right, it's usually just like, he had a fever.
Exactly. A fever, a rash, a cough, that could be literally anything. But eclampsia is so visually distinct, so unmistakable, that the descriptions from millennia ago perfectly match the clinical reality today.
It literally shows up everywhere across the ancient world. The paper cites the Atharva Veda in ancient India, which describes these specific pregnancy convulsions.
Yep.
It's in early Chinese medical texts written by Wang Dumei. It's painstakingly detailed in Egyptian papyri. And of course, it was written about extensively by the heavyweights of ancient Mediterranean medicine, people like Hippocrates, Celsus, and Galen.
Just try to put yourself in the shoes of an ancient physician or a midwife observing this.
It must have been terrifying.
Unbelievably terrifying. You have no concept of blood pressure. The circulatory system won't be fully understood for thousands of years. You have no concept of kidney function or protein in the urine or endothelial inflammation.
Right, you're just looking at the surface.
Exactly. What you observe is a pregnant woman, usually in her third trimester, who suddenly starts complaining of visual auras. She might say she sees flashing lights, or she might temporarily go blind.
Oh, man.
Then, without any further warning, she collapses into violent full-body convulsions. And if she survives the seizures, which unfortunately many did not, she frequently wakes up with profound post-seizure amnesia.
So she doesn't even remember it happening.
She has absolutely no memory of the traumatic event that just occurred.
Which is horrifying. And because it featured those highly specific, almost theatrical symptoms, the visual disturbances, the violent shaking, the sudden memory loss, ancient societies didn't view this through a medical lens at all.
Not even a little bit.
The paper notes that across multiple cultures, the prevailing belief was that the mother was suffering from demonic possession, or that she had been cursed by witchcraft.
And honestly, that is an entirely logical conclusion, given their framework for understanding the world.
Really? You think so?
Oh, absolutely. Think about it. If a perfectly healthy young woman is suddenly inexplicably struck down by an invisible force, in fact, the word eclampsia eventually stems from the Greek word for lightning, or a sudden flashing forth.
Oh, that makes so much sense.
Right. You assume malevolent, otherworldly forces are at work. Lightning strikes from the gods. Eclampsia strikes the mother.
And this belief system profoundly shaped early human psychology and culture. The source details how this led to all sorts of elaborate, desperate cultural practices designed to protect pregnant women.
They were trying anything they could.
They really were. They would wear specific, consecrated amulets. In some cultures, they wore these intricate ceremonial adornments, like heavy shell headdresses, specifically to ward off whatever evil spirit was causing these birth-associated convulsions.
They were throwing everything they had at a ghost.
Which brings us to the pivot point of the narrative, I think. Moving from ancient mystical history to a very real, very modern medical frustration.
Yes.
Because it's easy to look back at the Egyptians or the ancient Greeks and think, well, of course they thought it was demons. They didn't have science. You naturally assume that today, with our functional MRIs, our continuous genome sequencing, and our deep understanding of cellular biology, we must have this completely figured out.
Well, about that.
Right. Wait, I need to pause you there. Because this is the part of the paper where I genuinely felt a sense of cognitive dissonance.
It's jarring, isn't it?
It's beyond jarring. In 2026, despite all of those medical advancements, the exact root cause, the fundamental etiology of preeclampsia, is still unknown.
Still unknown.
How is that even possible? We can land a rover in a specific crater on Mars. We can use CRISPR to edit the genetic code of a living organism. But a pregnancy complication that we have been actively documenting and trying to cure for 5,000 years still has the global medical community stumped.
It sounds impossible, but it's the reality of maternal medicine. Back in 1916, a prominent physician named Zweifel actually dubbed eclampsia the disease of theories.
The disease of theories.
Yeah. He called it that because every major medical institution had a different hypothesis about what caused it, but absolutely nobody could definitively prove the underlying mechanism.
And that was over a century ago.
Right. And according to Robillard and his co-authors in this 2026 paper, that label holds up remarkably well today. Researchers now often refer to it as a syndrome of theories.
But surely we aren't completely in the dark. I mean, we know how to treat it, don't we?
We know how to manage the symptoms, yes. We can administer magnesium sulfate to prevent the seizures, and we can use antihypertensive drugs to lower the blood pressure.
Okay, so we can keep the mother stable.
Stable-ish.
Yeah.
But the only definitive cure we have, the only way to actually stop the disease process, is to end the pregnancy.
Wow.
We have to deliver the baby, and, crucially, we must deliver and remove the placenta. Once that placenta is physically removed from the mother's body, the maternal symptoms, the skyrocketing blood pressure, the widespread multi-organ inflammation, they begin to resolve.
Okay, so the placenta is the scene of the crime.
It absolutely is.
The mother is fine before it grows. She gets violently ill while it's inside her, and she recovers once it's gone. Which means if we want to solve this mystery, we have to figure out what the human placenta is doing that the placentas of those other 4,299 mammal species aren't doing. There has to be a mechanical difference.
And that search for the mechanical difference brings us directly to the defining feature of our species. The thing that sets Homo sapiens apart from every other creature on the planet isn't our bipedalism or our opposable thumbs.
It's the brain.
It is the sheer, unprecedented size, density, and metabolic complexity of our brains.
I think we take our brains completely for granted, honestly.
Oh, we definitely do.
We just assume, okay, humans are the smart ones, therefore we evolved big brains. End of story. We treat it like an upgrade to a smartphone. We rarely stop to think about the intense physical logistics of actually building a 3-pound, hyperdense neural computer from scratch, using raw biological materials inside a human womb.
And the logistics of building that brain are not just intense, they are terrifyingly aggressive.
Aggressive is the right word.
This is where the paper highlights a monumental medical breakthrough from the 1970s. A researcher named Brozens, along with his colleagues, discovered a physiological process called human-specific deep trophoblastic invasion.
Trophoblastic invasion. I mean, even the medical terminology sounds like a hostile takeover.
In many ways, it behaves exactly like one. To understand this, we need to look at the trophoblast. This is the outer layer of cells of the very early embryo, the blastocyst.
Okay, so these are the baby cells.
Yes. It's the specialized tissue that will eventually grow and develop into the placenta. What Brozens discovered is that in humans, this placental tissue doesn't just politely attach itself to the surface of the mother's uterine wall, absorb some ambient nutrients, and call it a day.
Like it does in other mammals.
Exactly.
Yeah.
Instead, it actively, deeply invades the maternal tissue.
And it has to do this because of the brain, right? Because building that massive neural network requires an absolute fire hose of energy and oxygen.
Precisely. The fetal human brain is an extreme energy sink. A standard mammalian placenta, say, in a cat or a sheep, mostly relies on a shallower connection. The maternal blood vessels stay relatively intact and nutrients just diffuse across a barrier.
Like a slow drip.
The slow drip, yeah. But the human fetus cannot survive on passive diffusion. It needs a massive, high-pressure, dedicated pipeline of maternal blood to feed that rapidly growing brain.
So the placenta deploys specialized cells, specifically called the extravillous cytotrophoblast.
The extravillous cytotrophoblast.
Got it. And it sends them migrating deep into the mother's uterine wall. And they aren't just like exploring the neighborhood. The paper details how they are actively seeking out and physically remodeling the mother's circulatory anatomy. They specifically target her spiral arteries.
Yes, the spiral arteries are the crucial supply lines. In a non-pregnant state, these arteries supply blood to the lining of the uterus. They are narrow, highly muscular blood vessels that are designed to constrict and relax, regulating blood flow based on the mother's own physiological needs.
So the mother's body is in control of them.
Normally, yes. But the invading fetal cells essentially paralyze and reconstruct these arteries. The fetal cells strip away the mother's muscular lining and replace it with themselves, effectively transforming these narrow, high-resistance, controllable vessels into wide, flaccid, low-resistance pipes.
I was trying to visualize this while I was reading, and the best analogy I could come up with is a major home renovation.
Okay, let's hear it.
Imagine the baby is a highly demanding general contractor. They walk into the mother's house, take one look at the standard electrical grid, and realize this standard wiring is absolutely not going to provide enough juice for the giant, state-of-the-art entertainment system, the brain that I have been hired to build.
That's a great way to picture it.
Right. So instead of just plugging into a wall outlet, the contractor aggressively takes sledgehammers, knocks down the mother's load-bearing walls, and splices their own thick cables directly into the city's main power line coming into the house. They bypass the home's circuit breakers entirely to guarantee an unstoppable flow of power.
That is a remarkably accurate mechanical analogy. The fetus is literally overriding the mother's standard physiological controls to guarantee its own nutrient supply. The mother can no longer constrict those arteries to restrict blood flow to the uterus. The baby is taking complete control of the tap.
But taking that analogy a step further, what happens if the contractor messes up? What if they are inexperienced or they hit a snag and they fail to do this deep structural rewiring properly?
Well, if the contractor fails, the whole house shorts out. In biological terms, if this deep trophoblastic invasion fails, or if it is incomplete, meaning those spiral arteries aren't fully penetrated and remodeled into wide pipes, you end up with what doctors call placental insufficiency.
The pipeline is just too narrow.
The pipeline is simply too narrow. The placenta cannot draw enough blood flow to support the immense energy demands of that growing fetal brain.
And the immediate result for the baby is fetal growth restriction, or FGR. The baby is starved of resources, so it stops growing at the optimal rate.
Right. And if this were a simple, isolated system, the story would end there.
The pipeline is small, so the baby is small.
Exactly. But it doesn't stop there. This is where the biological drama escalates into a life-threatening maternal disease. Because the placenta isn't just a passive tube, it is a highly active endocrine organ.
It produces hormones.
Hormones, chemical signals, you name it. When it doesn't get enough blood, it begins to suffocate. It becomes hypoxic and intensely stressed. And a stressed human placenta does not suffer in silence.
What does it do?
It starts dumping a massive cocktail of highly toxic anti-angiogenic factors directly into the mother's bloodstream.
It's like a chemical distress signal that accidentally acts like a poison to the host.
Exactly. The placenta is essentially screaming for more oxygen, but the chemical signals it uses to try and force more blood flow end up severely damaging the mother's vascular system. This toxic cocktail triggers a massive systemic inflammatory response in the mother. It specifically attacks her endothelium.
Let's clarify the endothelium for a second. That's just the thin intercellular lining of your blood vessels, right?
That's right.
So if that lining gets inflamed and damaged, we aren't just talking about a localized problem in the uterus. We are talking about a crisis affecting her entire circulatory system.
Every single blood vessel in her body is suddenly under chemical attack. This widespread endothelial dysfunction causes the blood vessels to constrict inappropriately and become leaky.
Leaky? Like fluid is escaping.
Yes. Fluid starts leaking out of the circulatory system into the surrounding tissues. Clinically, this is the exact moment preeclampsia begins. The mother's blood pressure skyrockets due to the constricted vessels. Her
Hmm.
kidneys, which rely on delicate capillary networks, get damaged and start leaking vital proteins into her urine.
Which is the proteinuria mentioned in the paper.
Right. And if the inflammatory storm isn't stopped, it rapidly progresses, damaging the liver, compromising the lungs, and eventually reaching the brain.
Which is what triggers the eclampsia, the lightning strike.
Yes, the grand mal seizures are the final, most catastrophic cerebral manifestation of this systemic endothelial damage. The blood vessels in the mother's brain begin leaking fluid, causing cerebral edema swelling and creating absolute electrical chaos in the neural pathways.
So, stepping back, what we are really looking at here is a fundamental, almost cruel evolutionary conflict.
Cruel is a good word for it.
The baby's relentless biological drive to grow a giant brain absolutely requires this aggressive, deep, tissue-destroying invasion into the mother's blood supply. But if that highly complex invasion goes even slightly wrong, the biological fallout threatens to quickly and violently kill them both.
That is the paradox of human reproduction. It raises an incredibly urgent biological question.
Which is?
Why does the invasion go wrong in the first place? If the survival of our entire species depends on successfully building these big brains, why hasn't evolution perfectly optimized this process over the last few million years? Why is the contractor failing so often?
Hold on, let me make sure I'm getting to biology right before we answer that, because this is where the paper introduces a twist that I honestly had to read 3 times to fully grasp.
I know exactly what you're going to say.
It's the immune clash,
Yeah.
and specifically the role of the father in all of this.
Yes. The concept of prima paternity. This is perhaps the most crucial piece of the puzzle, particularly when we examine the most dangerous, lethal manifestation of this disease, early onset preeclampsia, or EOP.
The paper makes a very clear distinction here. Most people who have heard of preeclampsia think of it as something that happens right at the very end of pregnancy. But early onset preeclampsia happens before 34 weeks, and it is exponentially more dangerous.
Exponentially.
And the authors explicitly state that this early onset version is fundamentally a failure of the mother's immune tolerance to paternal antigens.
To really understand this, we have to look at the fetus not just as a baby, but as a semi-allograft.
A semi-allograft, meaning like a transplant.
Exactly like a transplant. From the perspective of the mother's immune system, the fetus, and by extension the invading placental tissue, is a foreign entity. Half of the genetic code driving those invading cells belongs to the father.
It's half alien tissue, and our immune systems are relentlessly, ruthlessly trained from birth to seek out, identify, and destroy foreign tissue. That's how we survive a world full of viruses, bacteria, and parasites.
Exactly. So for a human pregnancy to even be possible, let alone successful, the mother's immune system has to do something incredibly difficult. It has to establish a highly specific, highly localized state of tolerance.
Almost like a localized ceasefire.
Yes. As these fetal cells are aggressively invading her uterine wall and physically tearing apart her spiral arteries, her local immune cells have to look at this half-foreign genetic signature and decide, okay, I recognize you, I will temporarily suppress my defensive protocols and allow you to proceed.
But doesn't that contradict everything the immune system is built for? It's a biological tightrope walk. The mother's body has to lower the shield just enough to let the baby's contractor build the power pipeline. But if she lowers them too much overall, she becomes dangerously vulnerable to actual lethal infections. How does the immune system even know to stand down?
It relies on a complex system of chemical recognition. And the paper highlights a fascinating, undeniable epidemiological pattern that proves this immune mechanism is at the heart of the disease.
What's the pattern?
This severe, early-onset preeclampsia predominantly affects 2 specific groups of women. First-time mothers, known as primipares, or mothers who are having a baby with a new partner.
Primipaternity, meaning first father.
Precisely. If a woman has had, say, 3 perfectly healthy, uncomplicated pregnancies with one partner, her immune system has successfully learned to tolerate that specific set of paternal genetic signatures.
It recognizes the blueprint.
Yes. But if she then gets pregnant by a completely new partner, her immune system is suddenly encountering a totally unfamiliar set of paternal antigens, and her risk of developing severe preeclampsia spikes right back up, statistically mimicking the risk of a first-time mother.
Because her immune system is looking at the invading placenta and saying, wait a minute, I don't recognize this new genetic passport. This isn't the guy from last time. This is an unknown invader.
See that?
And because it doesn't recognize the signature, it mounts a defensive attack on the placenta, partially rejecting it, which physically prevents those fetal cells from completing that deep artery remodeling we talked about.
Which then traps the pregnancy in that lethal cascade we outlined earlier.
Right. The shallow invasion leads to a starved, stressed placenta, which dumps the toxic factors, which triggers the maternal endothelial inflammation, the soaring blood pressure, and potentially the eclamptic seizures.
It all connects perfectly. And what I found so brilliant about the historical context the paper provides is that modern immunologists are just now working out the cellular mechanics of this, using electron microscopes and genome mapping.
Yeah, high-tech stuff.
But a French obstetrician actually noticed the clinical reality of criminal paternity way back in the 17th century, using nothing but his own observation.
Yes, François Morisot. He was a pioneering figure in obstetrics. In his 1694 textbook, Le Traité des Femmes Grosses, he meticulously recorded his observations of thousands of births.
And he obviously had no concept of paternal antigens, natural killer cells, or immune tolerance.
None of it.
But he saw the undeniable clinical pattern. The first time a woman's body encounters the process of growing a baby, the risk of her suffering violent convulsions is vastly higher than in subsequent pregnancies. He recognized the danger of the first encounter, centuries before we understood the biology behind it.
Just as a quick historical sidebar, the paper also mentions a physician named Boissier de Sauvage. In 1739, he was the one who finally gave the condition its modern, appropriately badass name, eclampsia.
The lightning strike.
Right. As we mentioned, it comes from the Greek for lightning, which perfectly captures the terrifying, out-of-nowhere violence of the seizures Morisot was observing.
That's a very fitting name. But if we pull back from the history and look at the evolutionary implications of this immune clash, it looks like a catastrophic design flaw in our species.
Right. I'm trying to wrap my head around this. In order to pass on our genes, in order to grow these big, brilliant, tool-making human brains, we are entirely reliant on a reproductive system where the mother's immune system is constantly teetering on the edge of rejecting the placenta and triggering a lethal inflammatory storm.
The margin for error is razor thin.
So how on earth did Homo sapiens survive this? Why didn't we just go extinct from maternal mortality 100,000 years ago?
If human pregnancy is inherently this dangerous, how are there over 8 billion of us walking the planet today? That exact paradox is what led the researchers to identify a brilliant, life-saving evolutionary cheat code.
A cheat code.
A deep biological safety mechanism that modern humans somehow developed to survive the deadly cost of our own big brains.
Okay, let's explore this evolutionary safety valve, because the sheer math presented in the paper is terrifying. The authors lay out what the stakes of this immune clash really are. Historically, before the advent of modern blood pressure medications and surgical interventions, eclampsia affected roughly 1% of all human pregnancies.
Which, from a population genetics standpoint, is already a massive, heavy burden for a species to carry. Consistently losing 1% of your reproducing females, along with their infants, to a violent neurological event, is a huge evolutionary handicap. It actively works against population growth.
But the paper argues that without our evolutionary safety valve, it would be infinitely worse. We somehow incredibly managed to decouple the maternal disease preeclampsia from about 75% of the cases where the baby's growth is restricted due to placental failure.
We really need to unpack what the word decoupling means in this context because it is the literal key to our species' survival.
Let's do it.
Earlier, we established the chain of events. If the placenta fails to invade deeply due to that immune clash, you get a small, starved fetus, fetal growth restriction,
Right.
or FGR, and the stressed placenta poisons the mother, causing preeclampsia.
Right.
Biologically speaking, those two things, the restricted baby and the inflamed mother, should always inevitably happen together. They are cause and effect.
The failed invasion causes the stress causes the poison causes the maternal disease. It's a straight line.
It should be a straight line, but in modern humans, the line is broken. They do not always happen together. In fact, the data shows that 75% of the time a placenta fails to implant deeply and remodel those arteries, we see a baby that is born small, what obstetricians diagnose as placental small for gestational age, or SGA, but the mother never develops the life-threatening preeclampsia.
The toxic cascade never happens.
Exactly. We somehow broke the circuit. We evolved a biological circuit breaker. In modern Homo sapiens, if the deep invasion fails, the maternal fetal system somehow recognizes that triggering a massive systemic inflammatory storm is mutually assured destruction.
It will likely kill both the mother and the baby.
So the system trips the breaker. It makes a ruthless evolutionary compromise. It sacrifices the optimal growth of the fetal brain, meaning a baby is born significantly smaller than its genetic potential, but it suppresses the lethal maternal syndrome. The mother's life is spare.
Going back to our analogy, the contractor fails to tap the main power line, so the house doesn't get the giant state-of-the-art entertainment system. But because of the circuit breaker, the entire house doesn't burn to the ground.
That's exactly it. Evolution chose the lesser of two evils. We sacrifice optimal, maximum fetal brain growth in order to ensure maternal survival. And by doing so, we ensure that the mother lives to potentially reproduce again, perhaps with a partner whose antigens her immune system tolerates better.
And the mathematical projections the paper provides to illustrate the importance of this circuit breaker are just bone-chilling. They estimate that if modern humans did not have this protective decoupling mechanism, if every failed invasion resulted in maternal disease, preeclampsia rates wouldn't be the 2 to 8% we see in hospitals today.
No, they would be much higher.
They would soar to a catastrophic 10 to 20% of all pregnancies.
And eclampsia, the actual lethal grand mal seizures, would skyrocket to affect 4 or 5% of all births.
1 in 20 pregnancies ending in violent convulsions, with sky-high maternal and fetal mortality. If you try to map that onto small prehistoric hunter-gatherer groups, a 5% maternal mortality rate from just one specific condition would be utterly devastating. It would severely, perhaps terminally, impede their reproductive success.
It would make long-term species survival nearly mathematically impossible. A population cannot replace itself if reproduction is that lethal. Which brings us finally to the central, groundbreaking hypothesis of this entire deep dive.
Right. So if this biological circuit breaker is the only thing keeping modern human mothers alive during complicated pregnancies, what happens to a species of prehistoric humans that evolved a massive brain that needed that massive blood supply but didn't get that genetic software update?
That exact scenario brings us face to face with the tragedy of the Neanderthals.
This is where the paper just utterly shifts the paradigm, because it connects everything we've just talked about, the deep placental invasion, the immune clash, the circuit breaker, back to those dusty bones on the paleoanthropologist's corkboard.
To truly understand the Neanderthal tragedy, we have to look closely at what they shared with us, and crucially, what they lacked. First, we know from an extensive fossil record that Neanderthals had massive brains.
Massive.
In fact, on average, their cranial capacity was even larger than ours.
And bigger brains mean they needed an even bigger, more demanding energy pipeline.
Exactly. Because they were members of the genus Homo, closely related to us, they undoubtedly shared our specific method of deep hemocorial placentation. They absolutely required that aggressive, deep trophoblastic invasion to forcefully remodel the maternal spiral arteries and feed those massive fetal brains.
They had the same aggressive general contractor knocking down the walls of the uterus.
Yes, they face the exact same intense biological imperative we do. But here is the fatal flaw, the central paradigm-shifting hypothesis of Robillard, Saito, and Decker's paper. Neanderthals likely lacks the evolutionary safety mechanism that protects modern human mothers.
They didn't have the circuit breaker. When the invasion failed, the house burned down every single time.
The researchers build a compelling argument for this based on genetics. Because Neanderthals and modern humans diverged from a common ancestor roughly 500,000 years ago, there are crucial documented genetic differences between our species. The paper points to several specific areas of genetic divergence that would have made Neanderthals incredibly vulnerable.
Let's really dig into the mechanics of those genetic differences, because this is where the biology gets dense but absolutely fascinating. First, they mention imprinted genes. Explain what those are and how they affect a pregnancy.
Imprinted genes are fascinating. Normally, you inherit 2 working copies of a gene, one from each parent. But imprinted genes are chemically stamped or imprinted, so that only one copy is active, depending on whether it came from the mother or the father.
Okay.
In mammalian pregnancy, this creates a literal evolutionary tug-of-war at the cellular level. This is based on David Haig's kinship theory of genomic imprinting.
So the parents' genes are fighting each other inside the womb.
Essentially, yes. The father's imprinted genes generally act to extract maximal resources from the mother. From an evolutionary standpoint, the father's genes want to build the biggest, strongest, most competitive offspring possible, regardless of the cost to the mother.
Makes sense. What about the mother's genes?
The mother's imprinted genes act to conserve her resources. She wants the baby to survive, obviously, but she also needs to survive the pregnancy herself so she can have more babies in the future.
It's a ruthless biological negotiation. The father's genes are stepping on the gas pedal for growth, and the mother's genes are pumping the brakes to prevent her from being bled dry.
Precisely. And modern humans have evolved a highly complex, delicate balance of these imprinted genes to safely manage this intense conflict. The paper suggests, based on genomic analysis, that Neanderthals likely had a less evolved, less sophisticated system of imprinted gene regulation.
So they couldn't pump the brakes as well.
Exactly. When the placenta struggled, their genetic programming was less capable of managing that fierce resource demand, making maternal burnout and systemic inflammation much more likely.
The paper also leans heavily into something called KR-HLA interactions. Now, earlier we talked about the mother's immune system acting like a tense border crossing, where it has to check the unique chemical passports of the invading fetal cells. Is that what KRHLA is?
That is exactly what it is. KR stands for killer cell immunoglobulin-like receptors. These are the customs agents. They are receptors located on the surface of the mother's uterine natural killer cells.
Okay, and HLA.
HLA refers to human leukocyte antigens. These are the passports presented by the invading fetal cells, which carry the father's genetic signature.
So the KIR customs agents check the HLA passports to see if the fetal cells are allowed to cross the border and remodel the arteries.
Yes, it is a highly specific lock-and-key mechanism. Modern Homo sapiens have evolved an incredible, vast diversity of these KR and HLA genetic combinations. This massive diversity acts as a buffer, allowing us a relatively wide range of immune tolerance.
We accept a lot of different passports.
Right. But Neanderthals, as we know definitively from sequencing ancient DNA, had incredibly low genetic diversity. They lived in small, isolated pockets. Their immune interactions at the maternal-fetal interface were likely much less sophisticated and highly rigid.
Meaning the customs agents were much more likely to panic, reject the passport, and trigger a lockdown, resulting in a failed placental invasion.
Exactly. And lastly, the authors mentioned piezo-1 variants. These are mechanosensitive ion channels that literally help blood vessels sense and respond to changes in blood pressure and flow.
Okay.
Modern humans have specific variants that make our vascular systems highly resilient. The Neanderthal vascular system, lacking these specific modern updates, might have been far less resilient to the immense physical stress and high blood pressure of pregnancy.
So when you synthesize all of these genetic vulnerabilities together, the less evolved imprinted gene regulation, the rigid and poor KIR-HLA immune tolerance, the less resilient vascular variants, the conclusion is devastating. Neanderthals possessed the giant brains that demanded deep placental invasion, but they genetically couldn't decouple placental failure from maternal preeclampsia.
They had the vulnerability without the safety net.
I want to really explore the mathematics of what this means for them as a species. Let's try to paint the picture of this demographic collapse.
It's a grim picture.
It is. Imagine being a Neanderthal 40 or 50,000 years ago. You live in a small, isolated, nomadic band, maybe 20 or 30 people. We already know from the fossil record that they often suffered from severe inbreeding because their overall population numbers were so low and they were so isolated from other groups.
They were already living on a demographic knife edge.
Now, add this grim biological reality to their daily lives. Every single time a female in your tribe gets pregnant, and especially if it's her first child or a child with a male from a neighboring tribe, triggering that prima paternity immune clash, there isn't just a small modern risk of complications. There is a staggering 10 to 20% chance she develops a terrifying, lethal hypertensive condition.
It's a massive risk.
She develops high blood pressure she can't feel, organ failure she can't see, which ultimately leads to a 4 to 5% chance she dies of violent, inexplicable seizures.
And remember the historical context we discussed earlier. Eclampsia is the first human disease ever documented by our ancestors because it is so profoundly traumatic and visually horrifying to witness. Imagine the deep psychological and cultural toll on a small, tightly knit Neanderthal community, repeatedly watching their young women and their unborn children perish in such a sudden, violent manner over and over again.
It is the math of a demographic collapse. If you have a tribe of 30 people and you have 5 reproducing females, and every pregnancy carries a 5% risk of maternal and fetal death, your population is compound fracturing.
Can't sustain that.
You are losing your reproducing females at a rate that a small, isolated group simply cannot sustain mathematically over generations. They were bleeding out genetically. And what truly breaks my heart about this, and what makes this paper such a brilliant, piercing piece of science, is the massive, glaring blind spot it reveals in how we have studied human history.
It exposes the ultimate danger of scientific silos.
Exactly. Paleoanthropologists have spent decades an entire century, really, trying to explain what they politely call the low fecundity of Neanderthal communities. They know from analyzing the bones and running population density models that Neanderthals had incredibly low birth rates and high infant and maternal mortality. They weren't replacing their population, they were fading.
And because they approached the problem as anthropologists, they naturally searched for external anthropological reasons.
The usual suspects.
Right. Was the climate getting too cold during the last glacial period? Was food too scarce? Did the arrival of modern humans create a competitive exclusion principle where we outhunted them for resources?
But because anthropologists don't usually spend their wit ends reading the Journal of Reproductive Immunology, and because they don't typically collaborate with obstetricians, preeclampsia, the absolute principal complication of human reproduction, the disease that has haunted Homo sapiens for 5,000 years of recorded history, has virtually never been cited in mainstream literature as a possible explanation for Neanderthal extinction.
It is deeply ironic. You have brilliant obstetricians and immunologists in one academic building looking at placentas through electron microscopes, trying to solve the riddle of eclampsia.
Yeah.
And you have brilliant paleoanthropologists in another academic building on the exact same campus, looking at fossilized skulls, trying to solve the riddle of Neanderthal extinction.
And the definitive answer to both of their questions was trapped in the hallway between them. We have spent lifetimes looking for broken flint spears, or analyzing ice cores for climate data, or looking for signs of prolonged starvation. But the thing that might have truly wiped out our closest evolutionary cousins was simply the biological cost of trying to grow a giant brain without the correct genetic software update.
It's tragic, really.
The Neanderthals were essentially victims of their own evolutionary ambition. Their massive brains wrote metabolic checks that their reproductive immunology simply couldn't cash.
That is a profound and incredibly accurate way to summarize their fate. This hypothesis shifts the entire narrative of human evolution. We have always framed survival as a contest of who was the smartest, who had the best tools, or who was the strongest hunter.
It's always a competition.
Always. But this tells us that survival was actually about whose immune system could successfully tolerate the violently invasive process of growing a large brain. Homo sapiens didn't survive because we were necessarily better at killing mammoths. We survived because we evolved a microscopic biological circuit breaker that kept our mothers alive when the pregnancy failed.
Which brings us to the end of this incredible perspective-altering journey. Just to briefly retrace the path we took today, we started with ancient Egyptian papyri and the terrifying ancient belief that pregnant women were being struck by demonic lightning.
A long way from where we ended up.
We zoomed into the microscopic level to witness the aggressive biological invasion of the placenta, the literal wall-smashing home renovation happening inside the womb to feed the fetal brain. We explored the immune clash of primipaternity and the cellular border crossing. And finally, we uncovered a fatal genetic blind spot, the lack of an evolutionary safety valve that may have doomed the Neanderthals to a quiet demographic extinction.
And if there is an overarching lesson to be taken from this, it is the absolute necessity of breaking down academic silos. This brilliant breakthrough hypothesis only exists because doctors and evolutionary biologists finally looked at the exact same set of data together.
They finally talked to each other.
The obstetrician looked at the evolutionary history of the placenta, and the immunologist looked at the genetic divergence of prehistoric hominins.
It is a powerful, undeniable reminder that knowledge is most valuable and mysteries are most solvable when we force ourselves to connect the dots across totally different fields. When we force the people who spend their lives looking at the ancient bones to sit down and talk to the people who spend their lives looking at the living blood.
Truth rarely respects our arbitrary academic boundaries. Heliox is produced by Michelle Brucker and Scott Bleakley. It features reviews of emerging research and ideas from leading thinkers, curated under their creative direction with AI assistance for voice, imagery, and composition. Systemic voices and illustrative images of people are representative tools, not depictions of specific individuals. Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other episodes, responding to the content, and checking out our related articles at helioxpodcast.substack.com.